Good morning. So today we have a mix of parts again, mostly stainless and mixed in with a little bit of aluminum. Some of it has a lot of surface splash dross, some heavy dross as you see here, some lighter dross as you see on this 16 gauge stainless steel. Some of the parts don't have any dross at all and would only need edge rounding. So what we're going to do is we're going to use a combination of wide belt and cross belt to run these parts. These parts here have a little bit of surface splash and some very limited minute dross around the small holes. And with small holes it is like surface for the cross belt machine, so that is why you may need to remove that, but we'll try it, a wide belt sander. So first of all, we're going to go back here onto our NS for the wide belt sander, and then we will switch to the cross belt machine for the edge rounding. Yeah, and what we'll do here is we will start from thick to thin. We set it to the 13.1 millimeter that those bigger parts are, the three here. And we will simply run those at medium speeds through an 80 grit wide belt. So for that, we turn the wide belt on, we turn the conveyor belt on, set the conveyor belt, the medium low speed, and we are going to run the for this one here, I'm actually going to slow down a little bit. Now I can accelerate the conveyor belt. Caught them all, so that's very good. See, when you do the wide belt sanding, all you need to do is you need to remove the dross for the most part. You don't need to totally remove it. You still have some sticking on the edge here. You see the same thing here. That is fine. That will come off with the edge rounding. And you see we hardly remove any material from the surface. We can still see the markings on the part, which is fine. Same here. You see we press on the surface more than anything. The edges, by the way, are very sharp. If you look at them, hard to see on a phone camera, but they are sharp. They are so sharp that you would cut yourself if you use them. Okay, so this was the thicker stuff. Now, this is only edge rounding. We're not going to do anything with this. This is a 40 gauge material. Off this aluminum, I'm just going to take one for right now and going to run it through here. And for that, we need to set the material to a thinner gauge, 3.2. There we go, good enough. And fairly high speed, and we are just going to run this. And you see in aluminum, of course, you have very little dross. And we're going to see if we can't do the other aluminum in part number 2 and 3 just with edge rounding. Now on these parts we are going to have this little bit of dross on the top, not much, but only around the small holes. And I ran this part already through the cross belt machine. You see you get a very nice edge, but you don't remove all the dross on the small holes. So I'm going to still I'm not going to run this through here. Just as a sample, I will mark it for you where we say cross belt only, so that you have an idea what that looks like. Excellent. So we are going to take this down to 1.5. Very light dross, you don't need a lot. You're going to bring the speed down. And you know, I'm going to run one of those like I normally would diagonally, but the other two I'm going to run exactly with the grain. And I'm going to do the same with this here. High friction conveyor belt, all the parts very good. Come out clean, nice, looks good. Now, what we have on the reverse side, we have a little bit of splash where you enter from the top side. So we are going to clean that up as well. We are going to run, this was run diagonally, so we'll run this diagonally, and we will run these two nice, straight, and parallel. And we will run these here, parallel also again. Nice finish, nice and straight. Now I'll explain to you in a minute why I did that. Excellent. So this concludes our white belt portion, and now we can move over to the cross. So on the white belt unit, I will start with the aluminum, simply because I want to try that first, see if we can get this off. I'm just going to set the thickness on the dial down here, about 3.2. This is a medium setting. We know where we are with our brushes. We could go about a quarter crank more, that would be heavy. But I think for the aluminum, I will just keep it nice and light. And even though we have dross, we'll turn those cross belts on, full speed on the potentiometer, and about 3 feet a minute for the dross on the aluminum, which could be a little bit too much on the conveyor belt. We need to see. But we have 2 pieces. So we will take part number 2 and we will run it through the cross side angle so that we get off the bottom, but also that we are getting all. There we go. Remember for the dross part, and as you can see, we still have a little bit of that dross on here. So what we'll do is we will go a little bit slower and we will hit it a little bit harder on part number 3. So we will make that quarter turn, see what that does, and we go about 2 feet. There, it comes out a lot cleaner, so if you hit it hard, you probably will have an edge that is sufficient to get to the cross belt. But the aluminum dross is brittle. and that part should paint fine when you look at these edges, right? We have a little bit something left here. So, in comparison, of course, if we take the part that ran through the white belt sander and we're going to run it at the same angle, we are going to get very good at running. I'm actually going to speed it up again to about 4. Good edge rounding all around. There we go. So, keeping up is our administration. So this was wide belt plus cross belt, 4 feet per minute. This was, that I have this right, this was cross belt only, about 3 feet per minute, and medium pressure. And this was cross belt only, about 3 feet per minute, maybe a little slower, and heavy pressure. All right. So now real quick changeover. We're gonna go to our thick material that we ran through the belt sander. Like I said, everything is back to the put it on the belt, and while it is running, we're gonna go to the 13 that we need to have here. There we go. And we have, of course, the pressure also set very heavy. Stainless steel, we want to go slow. We want to go about 2 feet per minute. And we're going to see what that does. And then let's run the other part of longer to take out, so we're going to run the other part in parallel after we see what the result is. That looks like a very good edge. See the right lines around the part, inside and outside contours, also around the holes, of course the smaller the hole, the less you're going to see. The backside, we're going to run all the parts the same. So I'm just going to throw these 2 parts on, and we are going to remember this had a little bit of the dross left, so we're going to try this the same here and see what this does. So this was wide belt plus cross belt, 2 feet per minute, heavy, right? And then it is heavy, you hear here in the the down going on. So this is wide belt plus here we see it's interesting. So the cross belt didn't totally take out the remainder of that heavy slab. On the other half of the part, where we did remove it on the white belt sander, we have very nice edges. So we should have run this harder, slower on the white belt sander, probably with the quarter grit, 60 or even a 50 grit, in order to remove this remainder of the cut. Now, this is almost not noticeable to the touch. It is just visible to the eye. And it has very nice and round edge. So that would have required more white belt. Okay, so that was also 2 beats per minute. So now we're gonna take these thicker parts and we're gonna run the reverse side. And for that, as you can see here on the machine, we're gonna back up again about a quarter of a turn, make it a little lighter. Here we go. And we're going to run the back side all in one pass. That heavy, no problem. Ideally, you run them exactly at 45 degrees. So, and then we will get to our 11 gauge here. That'll be the next part that we'll run, thickness 3.1. And you see that it is very quick to change over to 150. So, back. Alright, so from here we go into this edge rounding. We have foil on the other side that makes it usually a little slimmer. Doesn't matter what you put apart, because the process always ran evenly, because it runs perpendicular for the finger in the picture. So you see the part holds nice, super nice edges, really beautiful. And now what I will do for you is I will run the coated side. Of course, the coating is loose here, so we're going to lose that. That's already gone at this point. I may actually pull that off so that we are not getting confused here. So like I say, this corner is off, but you will see it on the rest of the part. And for that, we'll go again a tad lighter, and we'll go at about 4 feet a minute. The potentiometer, the number on the potentiometer is approximately 1 foot less than the actual belt. Of course, it's just the number from 1 foot. And it just happens to be so. So here you see, we have the coating still firmly adhered, other than on the corner where it was gone and where it was burned off around the hole. But the edges, nice and smooth, and at the same time, still full protection, other than maybe 40 thousandths around the edges, not even 30 thousandths around the edges, where the belt removes the laser grade poly coating. goes on here. These are all done. And we are coming to our 60 gauge. So, with our 60 gauge, what we're going to do for right now is we're going to set the thickness again. And I can hear now we are slightly in the belt. We're going to go a little bit heavier again, so that we are getting more. We are going to run at about 3 feet a minute. And this is a part that ran diagonal through the cross belt. Through the white belt. So we are going to run that the way it would run in a combined machine. Cross belt lengthwise and white belt lengthwise and the cross belt sideways. These parts here we are going to run as if we just did the first pass on the white belt, then we took the parts out and we rotate them 90 degrees and we run them parallel to the grain, and you will see that it makes a super nice surface finish. And we are going to do the same thing with these parts, parallel to the grain. Here's our diagonal part. You can always see it in the cross frame. Right? Cross frame. Here you have parallel frame. And still very nice edges. We'll bring those around. The same thing, and this is the beauty of the cross belt. It really enhances your finish if that's what you want to do. You don't have to. More efficient, of course, to run in one pass diagonally and have that cross hatch if you only want to deburr, especially if you want to paint afterwards. Then this is the part of the cross hatch, and these are the parts that have run parallel. I will mark those up accordingly once I get back to the table. For the sake of keeping this video a little shorter, I won't bore you with all my writing. And it's up in the part. Then that concludes our business here today. I appreciate you sending the parts. And I encourage anybody out there, send us parts, try us. Crossbelt, the most efficient machine in terms of consumables, ease of use, and reliability, and the ability, of course, to run small parts.